So we're going to be talking about distributive property and combining like terms today. It's section 1.4. Distributive property is really just the distribution of multiplication from the outside of the parentheses to each term on the inside of the parentheses. And combining like terms is exactly that, combining the terms that look alike. X's with X's, Y's with Y's, numbers with numbers, etc., etc. But before we even begin that stuff, we need to cover some basics. All right, so let's do this. Everybody write down basics and put a number 1, and let's go through some review problems. All right, now here's a review problem. Like, let's say, how about x plus, or even better, let's say 2m plus 1e. What is 2m plus 1e? So 2m plus 1e is really saying something like, if I have 2 markers plus 1 eraser, what do I have? Do I have 3 markacers? No, you don't have 3 markacers. You have 2 markers on an eraser. You can't combine terms that are not alike. All right, so that's the first part of the lesson today. If you have 2 markers and 1 eraser, you just say 2 markers plus 1 eraser. So what's the answer here? 2m plus 1e. You can't really combine the terms that are not alike. That's the first fact, the most important part of this lesson right here. You cannot combine terms that are not alike, all right? But you could multiply terms. Like, let's say if I had 2 times, let's say x squared. Could I multiply 2 times x squared? Yes, that answer is 2x squared. Okay, so, but if I tried, everybody write this one down, if I tried 2 plus x squared, I can't do that. That's just going to be 2 plus x squared. You can't really add or subtract terms that are not alike. Like this is a number, this is an x squared. You can't combine those. So you just leave it. But you could multiply numbers with variables. You just put them together. Because after all, what does 2x squared actually mean? It means 2 times x squared. You guys cool with that? All right. So you could multiply anything. You could multiply x times x squared. You can multiply x times y. Let's actually do some more of these problems. Multiplying anything. I could say 3x times 5. Well, what's 3x times 5? I could multiply this. I can't add it. If it said 3x plus 5, I couldn't do that because they're not like terms. But 3x times 5, what's that? 15x, right? I mean, let's think about what this actually means. 3x means 3 times x, and then times 5, you could just move things around. It's called commutative property of multiplication, where you could switch 3 times 5 and then times x, and then that's where you get the 15 with the x, 15x. Okay? So you could multiply anything. It doesn't even have to be x's. I could have 2 times x squared times y to the third. You could multiply that, just write it all together. 2x squared, y to the third. But if I said add 2 plus x squared plus y to the third, you can't do that. You can't do that. So you would just rewrite it. 2 plus x squared plus y to the third. Okay, hopefully you guys are jotting down at least some of these examples so we could really understand how to distribute in a couple of moments. So let's do one that you could actually, that'll be a little more entertaining. How about 2x squared times 3x to the 5th? We could multiply this, all right? We can multiply anything, but you cannot combine unless it's like terms. Now, these are definitely not like terms. We're not trying to combine. This is all about multiplication. So what would my answer to this guy be? 6x to the 7th power. Okay? Now, if you guys are thinking, what the heck? How does this answer equal 6x to the 7th? Let me explain that right now so you guys will know how to do this. First of all, isn't all of this pure multiplication? Right there it does say 2 times x squared times 3 times x to the 5th. So when it's all pure multiplication, you could rearrange things, right? 2 times 3 is the same thing as 3 times 2. You could rearrange things. So let me put that 2 times 3, and then the x squared times the x to the 5th. So we all know that 2 times 3 is 6. And we know that there's multiplication. Now, what is x squared really? X squared is really a x times x. What's x to the 5th really? Oh, that's really a x times x times x times x times x. So how many x's are you actually multiplying together? 7 of them. So that's why I just add them up, and I'll get 6 times x to the 7th. That answer is 6x to the 7th. Okay? So mathematicians, they always look at what's going on in math and they create shortcuts. So what's the point of rewriting this x squared as x times x and x to the 5th as x times x times x times x times x, when you could just say when you're multiplying two terms with the same base, all you got to do is add those exponents. Do we understand that? I hope so. What if I had 2x to the 5th times 3y to the 2nd? What would my answer be? You can multiply anything, remember? What's 2x to the 5th times 3y to the 2nd? Anybody? Nobody has an answer for this? 6. And okay, I like the 6 because 2 times 3 is 6. But what about the x's and the y's? Yeah, you just rewrite it. X to the 5th, y to the 2nd. You just rewrite it. Cool? Now, if I tried to add 2x to the 5th plus 3y to the 2nd, I cannot do that. Those terms are not alike. It's like me trying to add 2 markers with 3 erasers. Can't do that. You guys with me? Okay, so you can't do that. In order for you to be able to combine, the terms have to be alike. So check this out. If I had like 2x to the 3rd plus 5x plus 4x to the 3rd, how many terms do I have here? Now, when I mean terms, I'm talking about the items that are being separated with pluses or minuses. I have 1, 2, 3 terms. Out of those 3 terms, which ones could I combine? The 2x to the 3rd with the 4x to the 3rd, right? Now, when we say combine, we are not multiplying. When we combine, we're actually thinking of money. And that's why whenever I circle, I include the sign that's in front, because that tells me if I have or if I owe. This is a positive 2x to the 3rd, so it's kind of like I have 2 of these x to the 3rds, and I have 4 more of these x to the 3rds. How many actual x to the 3rds do I have? A total of what? 6 of those x to the 3rds. You see how the exponents don't change? The deal is this. Exponents really are multiplication, right? So if you're multiplying, yeah, exponents will change. But if you're just combining like terms, exponents don't change. I have 2 of these. I have 4 more of these exact things. How much do I have? I have a total of 6 of those things. What about this plus 5x? You just bring it down. Plus 5x. Okay. Let's move on to today's actual real lesson. Ladies and gentlemen, on this handout, we have distributive property. And what is distributive property? It's simply to distribute the multiplication of a term from the outside of the parentheses to the inside. Okay. Now, even if you stick with the old PEMDAS, right, which you should always do PEMDAS, you have parentheses. What are you supposed to do? Zoom in and see if you could actually add x plus 2. Could you add x plus 2? No, because it's like saying I have 1 marker and 2 erasers. You can't do that, right? They're different terms. You have a letter, you have a number. You cannot add terms that are not alike. You could add x's with x's, numbers with numbers, but you can't add x's with numbers. All right. Anyway, so the parentheses, there's nothing to do. There's also addition, which you couldn't do. There's multiplication that you can do, and this is distributive property. Whenever I distribute, I like to circle the term that I'm going to distribute and draw arrows. 3 times x is 3x. 3 times 2 is 6, and there's a plus sign between it. Or another way of thinking of it is 3 times, and include that plus with the 2. Say 3 times positive 2 is positive 6. But you put that positive as a plus sign, which is the same thing. So all of these are distributive property examples. How about you guys try this one? Go for it. That is correct. The answer is 10x minus 6. You take that 2, multiply it by 5x, and that'll become 10 with the x, and then 2 times minus 3 is a minus 6. Moving on to number 3. Let's distribute here. Negative 5, and again, I like to circle and include the sign that's in front. That way I know I can think of it as a negative 5 instead of a minus 5. Negative 5 times positive 2x. What is that? Negative 10 with an x. That's right. And then negative 5 times, I like to include the minus sign and think of it as a negative 4. Negative 5 times negative 4? Positive 20. So that positive, I put it as a plus sign, right? Because if I didn't, it would look weird. It would look like 10x with a 20 without the plus. Put that plus sign if it's positive. Put the minus sign if it's a negative. So I'm pretty sure you guys could do number 4. It's exact. What's the answer to number 4? 2x minus 2. That's right. Distribute. You get positive 2x with a negative 2. Number 5. That one's interesting because it's just a minus sign. Now, if you were to distribute the minus sign and put it in front of the x, it's going to say a minus x. And you put that minus sign in front of that 7, it'll say minus minus 7. And what happens with the minus minus 7? Plus 7. That's right. There's your answer. Or another way of looking at it is to think, well, this minus sign means for me to change these signs. So that becomes negative, that becomes positive. Or even another way is to put that minus sign with a 1. That's really like a negative 1. Negative 1 times x is negative x. Negative 1 times negative 7 is positive 7. All these different ways of seeing that same problem. Last one, what's the answer there? 9x minus 9. Let's move on again to combining like terms. All right, now we already talked about combining markers with erasers. You can't do that. So again, it's all about combining the terms that look alike. The x's with the x's, the y's with the y's, numbers with numbers, x squares with x squares, x to the thirds with x to the thirds, apples with apples, oranges with oranges, right? Terms that are alike. So when you look at number 1 here, how many terms do you actually have? 1, 2, 3. Out of those 3, how many could you combine? 2. What are they? 3x and minus 7x. Again, include the sign that's in front because that's the only way to know if you are thinking of having this amount or owing this amount, right? Without the negative sign, you're not going to know if you have or you owe. Again, combining like terms is adding and subtracting. It's really like thinking of money. So if you have 3 and you owe 7, how do you end up? You owe 4 of those x's, right? And then what about this plus 2? Well, I just bring it down. Plus 2. There's my answer, negative 4x plus 2. Notice, guys, that when we're combining like terms, obviously there's no multiplication here. Why not? Because there's a plus sign and a minus sign between the terms. When you're multiplying, that's when exponents change. Like if I were to, well, let's say, I don't even have one up there, but let's say I had x times x plus 2. Right there, when I go x times x, that becomes x squared. Exponents change, right? But when you're combining 3x and minus 7x, the exponents don't change. It's like having 3 of those and owing 7 of those. You're going to owe 4 of those, right? What could I combine here? The positive 2x. The negative 9x, we are not multiplying. We are combining, which means adding and subtracting. So what's my answer there to positive 2x and minus 9x? Minus 7x, right? Okay. And how about that minus 3 with the plus 8? Bring it down. But as I bring it down, I might as well combine the negative 3 with the positive 8. Why is that? Because they're both numbers. They're alike. Again, remember, you could combine x's with x's and numbers with numbers. That's why I circled both of these because they combine to give me this. That's why I squiggly lined both of these because they combine to give me 5. And positive 5 would be the more appropriate answer. So there's your answer, negative 7x plus 5. Number 3. Could I combine all these 3 of them? No. What are the only things I could combine? The 3x squared and the positive 9x squared. Again, I include the sign that's in front because that tells me if I have or if I owe. So I have 3, I have 9. How much do I have? How much do I have? I have 12, positive 12. Now, 12 of what? Of those x squares. Notice exponents do not change when we're adding or subtracting. They only change when we multiply because exponents are really multiplication problems. What do we do with this minus 2x? Just bring it down. We're done. Combining like terms is not bad. Number 4, what could I combine? Always start with your highest exponent term. 3x squared, I could combine that with what? Negative 9x squared. And if I have 3 and I owe 9, how do I end up? Do I have or do I owe? Oh, so that means negative 6 of those x squares. Exponents don't change because we're not multiplying. We're just adding and subtracting. Now, how about when I combine this negative 2x with this positive 2x? Let's combine those. I owe somebody 2. I have 2. How do I end up? 0 with nothing, right? So you just scratch them out. You don't even have to write anything. I mean, if you wrote something, you could put plus 0x, but that's ridiculous, right? There's nothing there. So just don't even write it. All right, what else? There's a plus 8 up there that we forgot about. Well, not really, but that plus 8, we can't combine it with any other number, so we're just going to bring that down. So there's my answer, negative 6x squared plus 8. Number 5. Okay, now we are combining like terms. We're thinking of money. Even before starting to combine the like terms, let's go through and see if we have any minuses, which we do. This minus has to change the plus plus. And now let's actually combine the x squares with the x squares. I have a 3x squared here. That's a positive 3x squared. I want to combine it with this positive 4x squared. Notice that I'm including the sign that's in front. So if I have 3 of those guys and I have 4 of those guys, how much do I have so far? 3 plus 4 is 7, right? And then I have 5 more of those guys because it's a positive 5x squared. So what is 7x squared plus 5x squared? 12 of those exact x squared values. Exponents don't change when you're adding or subtracting. And then you move on to your x's. I owe 2 of those x's, but I have 1. So it's like I owe somebody $2, I have $1. How do I end up? I still owe 1 of those x's, right? Maybe I should do a different color. That guy and that guy gave me a negative 1x. And I don't even need the negative 1. I could just put negative x if I wanted to. And my final thing to combine, I have these, the number minus 4 with the number minus 6. Now, I'm combining. I'm not multiplying, right? So minus 4 means I owe 4 plus negative 6. That means I owe 6. I owe somebody 4. I owe somebody 6. How much do I owe? I owe 10. There's my final answer. I cannot combine anything else because they're not like terms. So let's get this straight, guys. Distributive property is the distribution of multiplication. So what is distributive property? It's really multiplying, right? Combining like terms. When I combine an x plus another x, I get 2 x's. What's combining? It's really just adding and subtracting. So when you're faced with both combining like terms or distributive property, according to PEMDAS, which one should you do first? Distributive property or combining like terms? Distributive property. Because distributive property is multiplication. Combining like terms is adding and subtracting. So of course you're going to multiply before adding and subtracting, right? That's what PEMDAS says. So when they tell you to simplify an algebraic expression, pretty much it's going to mean for you to do distributive property and combining like terms, and you always do distributive property first. So on number 1, you are not going to add 3 plus 2. That would be wrong. You need to multiply first before adding or subtracting. So you need to do distributive property first. Now, even if you were to think, PEMDAS, okay, parentheses, what do I do in here? I can't do anything. So what do I have left? I have multiplication and addition. What do I do first? I need to multiply first. So whenever you distribute, and that's what you're going to be doing first, distributive property, circle that sign of the term that you're distributing. Positive 2 times x is a positive 2x. And I'm going to put a plus sign in front. And then positive 2 times negative 4, what do I get? Negative 8. And then I bring down the 3 that's in front, and now I have 3 terms. And out of those 3 terms, which ones could I combine? The 3 and the minus 8. The number with the number. Okay, so what is 3 with the negative 8 combined? You have 3, you owe 8. Negative 5. Now, notice I'm going to put the 2x in the front because that's the way algebra organizes answers. They put any variable term in the front and any regular number at the end. And if you had a higher exponent term, like an x squared, you would write that even over here, or x to the third out here in the front. It's always going to be in order, highest exponent down to the smallest, down to the number by itself at the end. That's called a constant, by the way. Let's move on to number 2. Do I have any distributive property to do? Yes. What am I going to distribute? Positive 2. 2 times 3x. What's that? 6x. What's 2 times negative 4?
8.
Negative 8. And notice I write it as a minus 8, right? And then after distributing, I bring everything down. The 8, that was a positive 6x. I put a plus in front of it. And the minus 5x, bring that down as well. Now, out of those 4 terms, after distributive property, what could I combine out of those 4 terms?
6x.
Positive 6x with negative 5x. We are combining, what do I have? That's just 1x. And then how about that 8 with that minus 8? What happens there? Cancels out. What's my answer?
1x.
1x. That's it. That is my answer right there, 1x. Number 3 is a little more fun because you have 2 distributive property problems before combining like terms. So let's distribute the 5 times x, I'll get 5x. 5 times negative 1, I'll get negative 5. And then distribute the minus 3 times x, I'll get minus 3 with an x. And the minus 3 times negative 4, I'll get a positive 12. Now, out of these 4 terms, I could combine which ones?
5x.
There you go, the 5x and the minus 3x. So I want to circle the 5x, circle the minus 3x, and when I combine that in my mind, what do I get? 2 of those x's. And I could also combine the minus 5 with the plus 12. I owe 5, I have 12, how do I end up? I have 7, so that's why I put a plus 7 right in front. All right, let's, I guess, might as well, let's just do all of them here. 9 times 5? 9 times x? Negative 6 times x? Negative 6 times 3? Now, out of all those terms, what could I combine? The 9x with the minus 6x, and what do I get? You have 3 left over. How about 45, take away 18, that's 32? Positive 32, there's my answer. Moving on. This one's interesting. PEMDAS, it tells you to zoom in and do this, right? But there is nothing to do in here. So what are we going to do? Distribute, right? The multiplication, right? So let's distribute that multiplication of positive 6. 6 times x is positive 6x. 6 times negative 1, negative 6. Notice I put it as a minus 6. And I'm going to bring down the 8 that was out here, the bracket, and the 7x out here in the front. Anyhow, I'm still with brackets. So inside the brackets, what could I do now? 8 with the minus 6. Perfect. 8 with minus 6. What is 8 minus 6? 2. So again, let me rewrite the bracket. And let me just leave the 6x that I didn't do anything to. Let me bring it down. And we said 8 minus 6 was positive 2. And we still have a 7x out here. Just bring that down. So we now have a distributive property problem right here. 7x times 6x. And then 7x times 2. So what is 7x times 6x? 7 times 6 is 42. But what about the x times x? What's that? That's an x squared. See, exponents do change when you're multiplying. Okay. And then how about over here, 7x times 2? That is a 14, but with an x. So there's your final answer. 42x squared plus 14. X. Sorry, I just said 14. 14x. Let's move on to the last one. That one's ridiculous. Yeah, we're going to have to distribute. You know what? How about this? Try to do it. I'll post the answer in a couple of seconds. Ladies and gentlemen, again, you want to distribute before combining like terms. So what I did, I went to every single term that had parentheses, went to the outside term and distributed. Got this for my distribution of 6. Got this for my distribution of negative 3. This one didn't have anything, so I just brought it down. I distributed right here, got negative 20x minus 4. And the plus 4, the nothing, I just brought it down. So after distributing, you got to multiply first before adding or subtracting. Now you could add or subtract. So let's combine all the terms that are alike. This 30x, combine it with the negative 3x. So far that's 27x. But if you take away 7, that's now negative 20x. And when you combine that with the minus 20x, that becomes no x's, right? Think about this. 30, take away 3, is 27. Take away 7 is 20. Take away 20 is nothing. Once again, 30, take away 3 is 27. Take away 7 is 20. And 20, take away 20 is nothing. So there's no more x's. Technically, all of these x's canceled themselves out, and there are no more x's. Let's go for the numbers now. What about this minus 6 combined with that plus 6? That's 0, cancels out. What about the minus 4 with the plus 4? 0, cancels out. Your whole answer is 0. All that work for nothing, literally, right? Get it? Nothing, 0 is nothing. Okay, flip the paper over, And we have some more riddles with math. Okay? So, I'm not going to do this on the video right now, but I need you guys to work on this, simplify it, get an answer.
On all of them?
Yeah, on all of them.